Welcome to the Modern Agent series. This is a brand new sub-series where we learn about advanced multi-agent routing. This is part 1. This is the diagram from our previous series. This is where we connected our prompt node to our React agents at the backend via these conditional edges. And these conditional edges, we followed a system where we scanned the user message for specific words like weather, finance, email, etc. And based on that, we directed our traffic to the right agent. But at scale, this architecture is not very robust because human messages don't work that way all the time, which makes our conditional edges not very dependable. Because of that, I am bringing in a new routing architecture. So this is the new plan. Welcome to the advanced multi-agent routing orchestration with mission control node, router node, and multi-test agent nodes. Here, we're going to make our prompt node a lot more smarter. We're naming it the mission control node. So this guy, using its LLM, it will create a decision object like this. It will no longer reply directly back to the user. That's not its job. It will take in the user message, analyze it, and create an intention data item expressing by a string like CRM or maybe stock, email, or research. And then it will include the context, the user message, and another data item, confidence, which is a number between 0 and 1, expressing the percentage of its confidence level on this intention. That's all. Then we take this decision message or object and pass it along to another smart node. I'm calling it router node. At this level, it will analyze this object and create more structural output, and this will be connected to the rest of our agents using this conditional edge. And based on that, we will be routing our traffic to the perfect agent like a stock agent, CRM agent, email agent, or research agent. If none of these matches, our decision object will contain unknown, and we will do something else with that. Maybe send back a hard-coded message. I haven't decided yet, but that's coming up. With that, let's go to the code. All right, so this is my usual setup. Installations, LangChain, LangGraph. These are my LangChain model functions to create LLMs. And let's look at the latest version of LangChain, 0.3.19 and 0.2.74. And here, I'm loading my API keys. These are all for the models I'm using. And this block is to connect us to our LangSmith portal for tracing and debugging. All right, so this is our main mission control graph. We're bringing in type-dict annotated for our state data structure. And then chat OpenAI, chat Grok. These are the main LLM functions from LangChain. And then state graph and end node coming in from LangGraph to create our main graph structure. Add messages is the reducer function that's going to be adding messages to our graph. And last but not least, human message and system message. These are the ones we're going to be using to give our message a structure. All right, so this is where we start as usual by creating the state data structure by extending the type-dict class as a parent class. And this will hold our messages state annotated as a list. Basically, this will be a list of messages. And then we bring in this reducer function called add messages from LangGraph. That will keep adding new messages to our graph messages state. Then we create our graph builder by instantiating state graph and passing the state as the data structure. And now this is the most important part. This is going to be our mission controller prompt, which is a system prompt. And this will shape and architect the characteristics of our mission controller. As you can see here, let's go through it. You are mission control, responsible for analyzing user input and determining the correct intent. You must return one of the following intents labeled as, basically these are the strings we're providing, CRM, stock, email, research. And if none of the requests match, you will return unknown. And then we're giving the structure of the object we talked about in the diagram, intention, context, confidence, and describing how they should be. And now we create our LLM. Here I'm using my champion model, GPT-4o, temperature 0.5. And this is my champion model because this guy is capable of participating in my agentic orchestration using LangGraph in every step of the way. And that's not true for all the models I've been using. It may be a powerful thinking model, but that doesn't mean it will be effective in an agentic orchestration. Because to be able to be effective, you have to be capable of three main things. Let me explain. All right, so this is what I mean. To be effective in agentic orchestration, any model must be able to do these three things: system prompting, tool usage, generate structure output. Let's start here. This is the most important one. Like I said, O1, O1 mini, these are great thinking models, right? But they cannot handle this system prompting just yet. And that makes them useless in my agentic orchestration. On the other hand, GPT-4o, 4o mini, and new kid on the block, Gemini 2.0 Flash, well capable of doing so. And that makes them primary candidates. And in this series, we're going to test out this new model, DeepSeek R1 Distilled Llama. Now, you guys probably know already at this point, DeepSeek API being very problematic. I mean, they stay down most of the time. They don't let you put more money into it, etc., etc. So that's why I choose this guy. This is a distilled Llama model based on DeepSeek R1 model. This is also a thinking model. And let me explain a little bit very quickly what this distilled Llama means. Welcome to knowledge distillation. They say knowledge distillation is the methodology behind the creation of the DeepSeek models, which basically means that a larger parent model or a teacher model is used as the data source in the training of the distilled models like DeepSeek R1, DeepSeek V3, DeepSeek Coder, etc. In this process, the student model keeps asking the parent model hundreds and thousands of questions and use those answers to train themselves. And because of that, the training time and cost can be reduced significantly. Following this process, the Grok services created DeepSeek R1 Llama model, where DeepSeek R1 itself was the teacher or the parent model, and the Llama 7DB model was the student. That's it. That's how we got our DeepSeek R1 Distill Llama 7DB model. Now let's go back. All right, so the number 2 would be tool usage. Now this is important when you're building agents, but there could be a model like DeepSeek R1 which may not be able to use tools very much, even the Claude Sonnet model, but the same model we can use as the mission controller or router model, as long as they support system prompting. So according to my tests, O1, O1 mini cannot use tools yet. Anthropic Claude models are not reliable when it comes to LangGraph, but as always, GPT-4o, 4o mini, and Gemini 2.0 Flash are champions of it. And probably we're going to find out the capabilities of DeepSeek R1 Distill Llama in this series. I'm not sure yet. Then last but not least, generating structured output, which is a must for inter-agent communication. Once again, O1, O1 mini, DeepSeek, these models, I'm not too sure yet because I haven't tested yet. Because what happens is, my logic is, once you disqualify for one of these two, this is out of the question. I mean, this is no longer even worth trying. As always, GPT-4o, 4o mini, Claude Sonnet, Gemini 2.0 Flash are well capable of doing so. So this gives us a nice picture of what to use, when to use it. Now let's get back to the code. All right, so now that we have our model created, now we focus on creating our mission control node. In here, we create our message object. We use system message and pass along the mission control prompt, which is the most important part, this mission controller node, and then pass the user message as human message, and then return the state messages object by invoking that LLM with this message. And then at this point, we're keeping it all simple. We just add this mission control node using graph builder add node, and using the same thing, the mission control, as the entry point and the finish point, so that we can test it out. Once all that done, we finally compile our graph using graphbuilder.compile, and then we launch it. Boom. This is our structure of our very simple mission controller graph. All right, so time to test our graph. We create our response variable by invoking this graph with this message. The user message would be asking, can you please get me my contacts? And here we're capturing our response, AI response, as an output and printing it out. Let's do that. Boom, there you go. How nice is that? And that's because of our GPT-4o LLM. It always does things correctly, most of the time. Still my champion model. So we are very close to our target here, but here's the problem. Even though this looks like a nice little JSON object, but when we type it to see what type this is, watch what happens. Oh, it says it's JSON, but look at the output type. It's a string. So that's going to be our problem using this mission control. We're going to have to add extra capabilities so that we can get a data dictionary or a JSON object out of this, which we will improve upon in the next video. But for now, let's go ahead and test some more, right? And as far as GPT-4o goes, I can guarantee you we're going to get the right message every time. So at this point, what we do, we disable this and enable this guy just to see what our DeepSeek R1 distilled Llama model does. So let's run it again and ask the same question. Whoa, look at that. Gave me the right answer, but it also gave me the whole thinking process. And the whole thing is also a string. So once again, even though it is a far greater model, more capable thinking model, but then this is going to be a problem we're going to be facing when it comes to handing this data over to our router. This is where we're going to need structured output and put this guy to test in our next video. But for now, let's test it out with these 4 questions. At this point, we're going to ask, how is Google doing in the market? Let's even move the market here. Let's make it more ambiguous. How is Google doing today? Let's see what it does. All right, we can read up on the whole thinking process, but look, it picked up on stock. This is our context. And now, since our question is a little bit ambiguous, its confidence level or certainty dropped by a little bit, but it's still 85% sure. All right, now let's go for the next one. What can you tell me about LangChain? This has to be research, right? Let's see. Oh, it's quicker and 95% sure that this is a research item. Gave us the whole object and its thinking process. Let's try the last one. Please send a message to Michael. Let's shorten it. Please message Michael. Yeah, just keep it simple. A little bit ambiguous. Let's see what the percentage drops or not. Let's see. Oh, still 90% sure. And this is email. Once again, it is still string. So in the next video, we're going to go ahead and bring in structured output so that we can get a data dictionary, Python dictionary, or a JSON object. With that, we finish this video. Thanks for watching.